You know that feeling, right? You've built something, it works perfectly on your machine, you're proud of it, and then you click deploy, and suddenly it all falls apart. It is one of the biggest headaches in development. So today, we're going to pull back the curtain on that invisible journey your code takes from your laptop to the live internet. I mean, if you're a developer, you've been here. You've probably said these exact words. You spend all this time building something. It runs like a dream locally. And then you push it out to the world and poof, it's gone. It is the sound of pure frustration. Or maybe you've gotten this lovely little message staring back at you. It feels like the internet is yelling at you in a language you don't understand, and you're just left there, totally guessing what went wrong. So what is going on here? Why does perfectly good code just break when it goes online? Well, the answer is in this hidden, invisible journey that your data takes every single time someone tries to visit your site. And in this explainer, we're going to map out that whole journey, step by step. So let's dive in. Okay, so our journey actually starts before a single piece of your app's data even gets sent. First things first, the user's browser has to figure out where to even go. And for that, it needs what's basically the internet's giant phone book. And that phone book has a name. The Domain Name System, or DNS. You've probably heard of it. Its job is super simple, but absolutely vital. It's the contact list for the entire internet. It translates the website names that we humans can actually remember into the numbers that computers actually understand. So when you type in www.google.com, DNS is the thing in the background that whispers to your browser, oh, they mean 142.250.185.46. I mean, can you imagine having to memorize a string of numbers for every single website you visit? No way. And what's really clever is how efficient this whole lookup process is. Your browser doesn't just immediately shout out to the entire internet. No, first it checks its own memory, that's the browser cache, to see if it's been there recently. If not, it asks around locally, on your network. Only then, if it still comes up empty, does it go on this bigger quest to find the one server that has the definitive, authoritative answer. It's this really smart, layered system designed to be as fast as possible. All right, so we've got the address. Now it's time to actually prepare our data for the trip. And you can think of this just like a postal service. Right? You can't just send a loose piece of paper through the mail. You've got to put it in an envelope. You have to package it up correctly. So the very first layer of wrapping is all about reliability. We take our data and we wrap it up inside something called a TCP header. This is kind of like putting your letter inside a numbered envelope. It makes sure that all the pieces arrive and that they can be put back together in the right order on the other side. Then, once that's done, we add the final delivery address. That whole TCP package gets put inside another, bigger package, and we slap an IP header right on the front. This is the main mailing label. This is what tells the package exactly which computer out of billions on the planet it needs to go to. And here's where it gets interesting. You actually have choices for your delivery service. On one hand, you've got TCP, which is like sending certified mail. It's a bit slower because it tracks everything and requires a signature, but you get a rock-solid guarantee of delivery. On the other hand, there's UDP. That's like regular mail. You just drop it in the box and hope for the best. It's way, way faster, which is perfect for things like video streaming or online gaming, where losing one tiny little packet of data isn't the end of the world. So our data has an address, it's all packaged up, and it's on its way. But we're not quite there yet. We still have to make sure it arrives at the exact right place, and just as importantly, that the conversation stays private along the way. So remember that IP address we found all the way back with the DNS lookup? Well, this is its moment to shine. It acts as that unique street address, guiding our little data packet through all the complex highways of the internet directly to the front door of the server. It's the final destination on that mailing label we made. Okay, the packet has arrived. Awesome. But on the modern web, just getting there really isn't enough. We have to ask the big question. Is this conversation private? Or could anyone who was along that journey have been listening in?
And that is where the secure handshake comes in. Before any of your real data gets exchanged, the browser and the server do this really quick three-step dance. First, they say hello and check what they're both capable of. Then, the server proves it is who it says it is by showing its ID card. That's the digital certificate. And finally, they both agree on a secret code, a set of encryption keys, that they'll use only for this one conversation. This whole process is what puts the S for secure in HTTPS.
And just like that, we've traced the entire journey. By understanding these invisible steps, you've basically transformed those confusing, frustrating error messages into a clear roadmap for debugging. You're not just a coder anymore, you're a network detective. This right here is the aha moment. That DNS probe finished NX domain error, you now know what that means. The internet's phone book couldn't find a listing for that address. That not secure warning in the browser? That means the secure handshake failed somewhere along the way. Your API failing only after you deploy it? Well, now you have a mental checklist. Could a firewall be blocking it? Is it a course policy on the server? You can suddenly see the matrix.
So what's the big takeaway here? You basically have new superpowers. You can now trace a request all the way from a browser to a server. You can intelligently diagnose why your app is failing online. You understand the language of these network errors. And all of this means you can build applications that are way more resilient and secure because you actually get what they're built on top of. And that really brings us to our final thought. Learning about this journey, it's not just a bunch of technical trivia. It's a fundamental shift in how you see the web. So the question I want to leave you with is this. Now that you can see the invisible journey your code takes, what are you going to build differently?